of distinct triplets XYZ satisfying XYZ x less than y less than z and x plus y plus z is equal to 1. So let us write the cases 1 to 9. Sum should be 12 and x less than y less than z. Next 1 3 8 1 4 7 1 5 6. In all the cases x less than y less than z and x plus y plus z is 12. Next 2 3 7. Sum should be 12. 2 4 6. That's all. Next 3 with 3 what are the possible cases? 3 1 8 not possible. 3 2 7 not possible. 3 4 5. 3 4 5. So altogether you get 7 cases. Option B. Next, a natural number n such that n factorial ends in exactly 1000 zeros. See, number of zeros at the end of n factorial is nothing but the exponent of 10 in that n factorial. That is, number of zeros depends upon the exponent of 10, that is power of 10. Power of 10 is nothing but power of 5. Power of 10 in any number will be same as power of 5 in that number. So now we have to find in which number the power of 5 will be 1000. For that there is a formula. To find exponent of a prime number, the formula is step of n by p. Step of n by p square plus step of n by p cube and so on. This is a formula for finding exponent of prime number p. Now let us find exponent of 5, because the power of 10 in any particular number will be same as power of 5 in that number. So exponent of 5 in n factorial, let us check with 4010. Let us say exponent of 5 in 4010 I am finding. This is nothing but step of 4010 by 5 plus step of 4010 by 5 square 25, 4010 by 5 cube 125, 4010 by 5 power 4 625 plus step of 4010 by 5 power 5 625 into 5. Let us find 625 into 5. 5 power 5 plus step of 4010 by 5 power 6 and so on. What is 5 power 5? 5 power 5? 625 5s. 3125. So this is 3125. Next one will be 3125 means 15,000 change will be there. 4010 by 15,000 will be 0 point something. So step of 0 point something is 0. So no need to find. If we simplify all this, 5010 by 5 means 800 point something. Step of 800 point something is 800. Step of 4010 by 25. Like that, if you go on simplify, you will get 1001 here. But the question is 1000 zeros should be there. But here power of 5 is 1001. Hence power of 10 will also be 1001. So 1001 zeros will be there for 4010. But we require the number which has 1000 zeros. So obviously it will be 4009. So take 4009 and find exponent of 5 and you will see that exponent of 5 in 4009 will be 1000. So option C is the correct answer. Next, the number of 4-letter combinations. Number of 4-letter combinations that can be formed with an English alphabet such that the number of distinct vowels is equal to the number of distinct consonants when repetition is allowed. We have 5 vowels and 21 consonants, and we have to form number of 4-letter combinations. Number of vowels should be equal to the number of consonants. Now let us say we have 2 vowels and 2 consonants in first case. Select 2 vowels 5C2 ways, select 2 consonants 2C2 ways, and arrange for 2 vowels and 2 consonants here, which can be arranged in 4 factorial ways. 5C2 is 10, 21C2 is 21 into 20 by 10, 210, into 4 factorial is 24. This is one case where we have 2 vowels and 2 consonants. Select 2 vowels from 5 in 5C2 base, select 2 consonants from 21 and 21C2 base, and now arrange these 4 letters in 4 factorial base. Next is, you can select 1 vowel in 5C1 base, 1 consonant in 21C1 base, and arrange those 1 vowel, 1 consonant in 4 factorial by 2 factorial, 2 factorial base. Because vowel will be repeated, that consonant will be repeated. Let us say I have selected AA and BP. Then you have 5C1 into 2C1 into 4 factorial by 2 factorial into 2 factorial. 5C1 is 5, this is 21, this is 24 by 4, 6. Add these two. While adding these two options, you need to check the options and accordingly you have to arrange. So 10 into 210 into 24 plus 5 into 21 into 6. So I can take 21 into 6 common. In 210 if I take 21 and if 24 if I take 6, what is left out? 10 here, 4 here. 10 into 4, 40, 400 plus 5. But how options were in terms of powers of 3? Let us write in powers of 3. $70 into something now. So this is 10 into 70 into 3 into 24 plus 5 into 7 into 3 into 6. Now let us take 70 common then. If I take 70 common, then 10 into 3 into 24, 720 plus, here I took 5 into 7, 35, we'll get 9 here. 35 to 70, 9 is left out. So 70 into 729, 729 is nothing but 3 power 6. Option C. Next, the number of 4-digit numbers that can be formed using all the digits except 0. Except 0 means we have to consider 1, 2, 3, 4, 5, 6, 7, 8, 9. And you have to find number of 4-digit numbers that can be formed using these digits except 0 such that every number has exactly 2 digits in it. Every number has exactly 2 digits in it. So first select 2 digits in 9C2 base, but we require 4 distant numbers. Select 2 digits and each place can be filled in 2 ways. 2 into 2 into 2 into 2 into 2. power 4. Now you have to subtract the cases where every number has exactly 2 digits in it and the number of 4-digit numbers. You have to subtract two cases, which means 9 into 8 by 2 into 16 minus 2. This is 36 into 14, 504.
Next question. Three sisters and eight other girls are together playing a game. Then the number of ways in which all the girls are seated around a circle such that all the three sisters are not seated together. See, all the sisters are not seated together means first you have to find total arrangements minus number of arrangements in which all the sisters are seated together. How many total arrangements are possible? Altogether 11. 11 members around a circle, 10 factorial s minus number of arrangements in which all the sisters sit together means consider 3 sisters as 1 unit, consider 3 sisters as 1 unit and remaining 8 girls as 8 units. Altogether 9 units can be arranged in 8 factorial ways and 3 sisters among themselves can be arranged in 3 factorial ways. So this 10 factorial can be written as 10 into 9 into 8 factorial minus take 8 factorial common. So this is 90 minus 6, which is 84. So 84 into 8 factorial, option B. Next. There are 10 red and 5 yellow roses of different sizes. X is the number of garlands that can be found with all these flowers so that no two yellow roses come together. No two yellow roses come together means first you have to arrange red roses. 10 red roses can be arranged in the form of a garland in 9 factorial by 2 because in the case of garland or beads in hanging type of permutations, the formula is n minus 1 factorial by 2. Since no two yellow roses come together, first arrange 10 red roses in the form of a garland in 9 factorial by 2 ways. And now there are 10 gaps between them for 5 roses, 5 yellow roses, which can be filled in 10 p5 ways. So between 10 red roses, there will be 10 gaps in circle. So 10 p5. Next, what is y? Number of garlands found with all these flowers so that all red roses come together. All red roses come together means consider 10 red roses as 1 unit and 5 yellow roses as 5 units. 6 units around in the form of a garland, 5 factorial by 2, and 10 red roses among themselves can be arranged in 10 factorial ways. So this is x and this is y. And now the question is 2 into x minus y by. Now this 10 p5 can be written as 10 factorial by 5 factorial. Now 2 into x minus y by 10 factorial is the required value for this. So 2 into in x minus 5, take 10 factorial by 2 common, then you get 9 factorial by 5 factorial minus 5 factorial. Now the question is finding 2 into x minus y. While finding x minus y, take 10 factorial by 2 common, then you get 9 factorial by 5 factorial minus 5 factorial divided by 10 factorial. So 10 factorial gets cancelled, 2 gets cancelled. So answer is option A. In how many ways can the letters of the word multiple can be arranged by keeping the position of vowels fixed? Vowels places are fixed. What are the vowels we have? U, I, E. Those places are fixed, which means You cannot change the spaces. Now the question is, how many ways can the letters of the word be arranged by keeping the vowels fixed? So fix those three vowels places are fixed. Now there are five consonants in which L is repeated two times. Those five consonants can be arranged in those five places in how many ways? 5 factorial by 2 factorial ways. Into these three vowels can be arranged among themselves in 3 factorials. So 120 by 2, 60 into 6, 360. Vowel should be arranged in those vowels places only. So three vowels can be arranged in three places in 3 factorial ways. Five consonants can be arranged in 5 places in 5 factorial by 2 factorial. What for this 2 factorial? L is repeated 2 times. So 360 option B. Next. 3 and 4 digit numbers are formed with the digits 1, 3, 5, 6, 8. These are the digits given. What is even? Even is the number of 3 digit even numbers with no digit repeated. So for the number to be even, last place should be either 6 or 8. When 6 is fixed here, other than 6, we have 4 digits, 2 places. 4p2 here, 12. Here also you get 4p2, 12. So altogether 24. So even is equal to 24. Is number of 3 digit even numbers. Next, E2 is number of 3 digit, sorry, E2 is number of 4 digit even numbers. For the number to be even, its last place should be either 6 or 8. So when 6 is fixed, 4 digits, 3 places. 4p3, which is 24. Here also you get 4p3, which is 24. So E2 is equal to 48 you get. Next, what is O1? O1 represents number of 3 digit odd numbers in which no digit is repeated. For the number to be odd, last place should be either 1, 3, 5. When 1 is fixed, 4 digits, 2 places. So 4p2, which is 12. Here also you'll get 12. Here also you'll get 12. Altogether 36. So O1 is 36. What will be O2? Number of 4 digit odd numbers. So here 1, 3, 5. So here you get 4p3, 24, 24, 24. So 3 24s you will get. So O2 will be 72. Now which of the given options are true? First option is even is equal to, first option is absolutely wrong. Look at third option. What is E1 plus E2 by 2? 24 plus 48, 72 by 2, which is 36, 6 square. O1 is 36, O2 is 72. 72 plus 36, 108 by 3, which is also 36. So option C is correct. Next, a person writes 6 letters to and addresses the corresponding envelopes. In how many ways can the letters be placed in the wrong envelopes so that placed in the envelopes so that at least two of them are in the wrong envelopes? At least two means minimum two should be there. So there, see in options, this is not S, this is R, and this is 2. R is equal to 2. Here also R is equal to 3. So at least two letters being the wrong means two letters wrong or three letters wrong or four letters wrong, 5 letters wrong or 6 letters wrong. At least two means this. What is the formula we have for out of n letters? Out of n letters, if r letters are placed wrongly, then the formula is npr into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial so on up to minus 1 whole power r by r factor. This is the formula for number of ways in which r letters are placed wrongly out of n. For us, r is equal to 2, 3, 4, 5, 6. So you have to add up all those. So this is nothing but sigma r is equal to 2 to 6. Write down that formula npr into this entire sigma r is equal to 2 to 6. What is n for us? 6. So 6 pr into this. Now npr is nothing but ncr into n factorial. npr is nothing but ncr into r factorial. So 6pr can also be written as 6cr into r factorial. So write this 6pr as 6cr into r factorial, and this notation is given as dn. So this will be dr, and 6cr is same as 6 is 6 minus r. What is this entire notation given in the question? Dr. This is given as dr. So what is the answer finally? Sigma r is equal to 2 to 6, 6cr into dr, or 6c 6 minus r into dr. Option C. Next, a question paper consists of two sections consisting of 3 questions and 4 questions in respectively. The following note is given on the paper. It is not necessary to attempt all the questions. So no need to write all the 7. But one question from each section is compulsory. In how many ways can a candidate select the questions? Minimum 1% from each section. So I can write 1, 1. I can select 1 here, 2 here, 1, 3, 1, 4. Or I can write 2, 1, 2, 2, 2, 3, 2, 4. Next, any more possibilities? I can select 3 here, 1 here, 3, 2, 3, 3, 3, 4. These are the possible selections. First selection can be made in how many ways? 3c1 into 4c1. Like that, second selection 3c1 into 4c2. Like that, write all the possible selections and then add all the cases, and you'll get the answer as 105. You know how to find 3c1 into 4c1, 3 into 4 12, 3 into 6 18. Like that, write all the possible here. 3c3 into 4c1, 3c3 into 4c2, 3c3 into 4c3, 3c3 into 4c4. Simplify and then add all this, so you'll get 105 cases, out of which you have to select 3. So how many triangles can be formed? MC3. Because out of m vertices, we have to select 3 vertices. So the number of triangles that are formed are MC3. So Tm is equal to MC3. So what is T? M plus 1? M plus 1 C3. So what is the condition given? M plus 1 C3 minus MC3 is equal to 15. Then what is the value of M? What is M plus 1 C3? M plus 1 into M into M minus 1 by 3 factorial. MC3 is M into M minus 1 into M minus 2 by 3 factorial. So what is common? M into M minus 1 by 6 is common. Then you get M plus 1 here minus M minus 2. So this is M into M minus 1 by 6 into 3 you get, which is 15. 3 2 times. So M into M minus 1 is equal to 30. Solve the quadratic equation, you get M or do by verification. What value of M satisfies M into M minus 130? M is equal to 6. 6 into 5 is 30. So option B.
2nc3 is to nc3 is equal to 12 is to 1. Then what is it? What is 2nc3? 2n into 2n minus 1 into 2n minus 2 by 3 factorial, which is 6, divided by nc3 is n into n minus 1 into n minus 2 by 3 factorial, which is given as 12. 6 gets cancelled, n gets cancelled. So 2 into 2n minus 1, here I can take 2 common, then I get n minus 1 by n minus 1 into n minus 2 is equal to 12. Now we can cancel n minus 1. So what is left out? 4 into 2n minus 1 is equal to 12 into n minus 2. From this, 8n minus 4 is equal to 12n minus 24, or 4n is equal to 20, n is equal to 5. Option A. Next, 22 PR plus 1 is to 22 PR plus 2 is equal to 11 is to 52. Then what is NPR? N factorial by n minus r factorial. So 22 PR plus 1 is 22 factorial by 22 minus r minus 1. That is 21 minus r factorial divided by 20 PR plus 2. 20 factorial by 20 minus r minus 2, which is 18 minus r factorial, which is 11 by 50. Now 22 factorial can be written as 22 into 21 into 20 factorial by 21 minus r factorial is 21 minus r into 20 minus r into 19 minus r into 18 minus r factorial divided by 20 factorial by 18 minus r factorial, which is known as 11 by 52. Now you can cancel 18 minus r factorial, you can cancel 20 factorial. So what is left out? You can cancel 11 two times here. 2 into 21, 42 by 21 minus r into 20 minus r into 19 minus r is equal to 1 by 50. Instead of solving, you better do by verification process. Okay. Verify from the options and check where you get the correct value of options. At an election, a voter may vote for any number of candidates not exceeding the number to be elected. If 4 candidates are to be elected out of the 12 contested in the election and voter votes for at least one candidate, then the number of ways in which a voter can vote. So, at an election, a voter may vote for any number of candidates but not exceeding the number to be elected. And how many numbers are to be elected? 4. So, maximum 4 you have to elect out of 12 and at least one candidate. So, 12C1, at least 1 means minimum 1 and maximum 4. So, the total number of ways of selecting the candidates will be 12C1 plus 12C2 plus 12C3 plus 12C2. This is 12. This is 66, 12C2, 12 into 11 by 2, 66, 12C3, 12 into 11 into 10 by 3 factorial, 6, 6 twos, so 220, 12C4, 12, 11, 10, 9 by 20, 12 twos, 2 fives, 55 nines, 494, 45, 495. Add all those, you get 793. Option A. Minimum 1 candidate, maximum 4 candidates. It's the number of 4-letter words that can be formed with the letters in the word equation with at least one letter. at least one letter repeated means total number of words minus number of words without repetition. At least one. Total number of words. How many words can be formed? Number of four-letter words that can be formed with the letters in the word with at least one letter repeated means formula is n power r minus n without total number of words minus number of words with repetition. N is how many letters are there in the given word? 8. R is 4. So 8 power 4 minus 8. Simplify 8 power 4 minus 8 before you get 6. N power r minus npr is a shortcut formula for finding the number of words with at least one letter repeated. Next question. The number of ways in which 4 letters can be put in 4 envelopes so that no letter goes into the envelope meant for it. This is derangement question. And we have a shortcut formula for number of derangements like this. N factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus so on up to minus 1 whole power n by n. Here n is equal to 4 for us. So out of 4 letters, no letter goes into the envelope meant for it. So derangements 4 factorial into 1 minus 1 by 1 factorial. Here n is 4. So you should write up to 1 by 4. So this is 24. These two gets cancelled. This is 1 by 2 minus 1 by 6 plus 1 by 2. 24 into 1 by 2, 12 minus 24 into 1 by 6, 4 plus 1. Answer is 9, option D. Now we have a formula for NPR like this. NPR is nothing but n minus 1 PR plus R into n minus 1 PR minus 1. From that, what is NPR minus n minus 1 PR? R into n minus 1 PR minus 1. Right? Now, instead of n, here we have m. So, what is MPR minus m minus 1 PR? R into m minus 1 PR minus 1. So, what is left hand side given in the question? A into m minus 1 PS is given, which is R into m minus 1 PR minus 1. So, what is A by comparison? A is nothing but R. S is nothing but R minus 1. That implies S is equal to A minus 1 or A minus S is equal to 1. Option A. Next, the value of 6p4 plus 4 into 6p3. This is a formula just now we discussed. Put n is equal to 7 here plus 7pr is equal to 6pr. Put n is equal to 7 and r is equal to 4. So 7p4 is equal to 6p4 plus 4 into 6p3. Now the question is finding the value of this, so which is nothing but 7p4. 7 into 6 into 5 into 4, which is 840. Options. Next, the number of ways in which 6 men and 5 women can dine at a round table if no two women are sit together. Since the condition is on women, first we have to arrange men. 6 men are there. 6 men are there. So arrange the 6 men around the round table in how many ways? 5 factorial ways, because the number of circular permutations formula for n things is n minus 1 factorial. So first arrange 6 men in 5 factorial ways. Since no two women should sit together, we have to arrange the women in between the gaps. How many gaps are there between 6 men? This is one gap, 2, 3, 4, 5, 6. 6 gaps for 5 women, which can be arranged in 6p5 ways. 5 factorial is 120, 6 factorial is, sorry, 6p5 is nothing. Okay, options are given in factorials. 6p5 is nothing but 6 factorial. So 5 factorial into 6 factorial, option A. Next, what is the rank of the word mother when all possible words are formed using all its letters and arranged as in dictionary? There is a shortcut method for finding rank of a given word. That method is like this. First write alphabetical order. What is alphabetical order of the letters of the given word? First we get E, H, M, O, R, T. So altogether 6 letters. This is the alphabetical order of the letters. Next, under that, whichever word rank is required, write down that letter. Write down that word mother. First write alphabetical order and then write the word whose rank is required. Now the shortcut method for finding rank is like this. Rank of the word mother is, listen carefully. First cancel M with M. How many letters are there before M? 2 letters, E and H. So 2 into. How many letters are there after M here? 5. For that you have to write factorial. 2 into factorial. Before M 2, so write the 2. After M you have 5. 5 plus. Next. Now cancel O. Before O how many letters? Again 2. E and H. After O 4 letters. T, H, E, R. 4 factorial. Plus. Next cancel T and T. Before T we have 3 letters. E, H, R. After T we have H, E, R. So 3 into 3 factorial you should write. Plus. Next cancel H. Before H 1 letter. After H 2 letters. So 1 into 2 factorial. Plus. E and E. Before E 0, after E 1, so 0 into 1 factorial plus last R. For that you should write 1 always. For the last cancellation you should write 1. Now simplify this. 2 into 120, 240. 2 into 24, 48. 3 into 6, 18. 1 into 2 factorial, 2. Plus 0 plus 1. Now simplify this. 309 is the rank of the given option B. Next, how many chords can be drawn through 21 points on a circle? On a circle, to draw a chord, how many points are required? 2 points. If you join those, if you select 2 points and if you join them, you'll get a chord. Like that. So for every selection of 2 points, you'll get 1 chord. How many chords can be drawn through 21 points? It is nothing but number of ways of selecting 2 points from 21, which is 21C2. 21 into 20 by 10 by 2, which is 210. Option B. Next, the number of ways of distributing 500 dissimilar boxes equally among 50 persons. Equally among 50 means 10, 10, 10, 10, 10. Like that, you have to distribute to 15 persons equally. So this comes under number of ways of division of dissimilar things into equal groups. This can be done in 5 factorial, 500 factorial by 10 factorial, 10 factorial, 10 factorial. How many times? 50 times. So 10 factorial whole power 50. There are 50 equal numbers here. So you should divide with 50 factorial. And we have to distribute to the persons. That should be multiplied with 50 factorial. So that these two gets cancelled. So 500 factorial by 10 factorial whole power, option D. X 9C3 plus 9C5 is equal to 10C8. Then what is R? 9C3 plus 9C5 is equal to 10C8 given. We know that NCR is nothing but NCN minus R. By using that, 9C3 can be written as 9C6. Now, this left hand side is in this form. It is in the form of NCR plus NCR minus 1, which is N plus 1C. So, what is 9C6 plus 9C5? By using that formula, 10C6. 10C8 is same as 10C2. I think it should be, sorry, 10C4. I think this is not 8, this is R. So left hand side is 10CR, 10CR. So this is 10C6 is equal to 10CR. So R is equal to 6. 6 is not there in the options. And 10C6 can also be written as 10C4. So that is equal to 10CR implies R is equal to 4. Option B. So this is 10CR, 10C. It is not 10C8. Next. The number of ways of arranging the letters of the word linear so that the letters N and R do not come together and E and A come together. E and A come together means consider those two letters as one unit. And what are the letters left out? L, I, N, R. And L, N and R should not come together. So first what you have to do is, since E and A should come together, consider them as one unit. Remaining 4 letters as 4 units. Now, another condition is these two should not come together, right? These two should not come together. So first you have to arrange the remaining letters. Remaining letters means this, this, this. 3 units, 3 factorial ways into these two among themselves, 2 factorial ways. So first arrange E, A, L, R. Since these two should come together, consider these two as one unit and remaining 2 letters as 2 units. So 3 factorial into 2 factorial. Since N and R should not come together, they should be arranged in between the gaps. How many gaps are there between these 3 letters? 4 gaps. 4 gaps for 2 letters, 4 feet. So 6 into 2 into 12, which is 144. Option D. Next. A, B, C are 3 particular persons among 10 speakers. So other than ABC, we have 7 speakers like this. The number of ways of arranging all the 10 speakers on the dais in a row so that all the 3 speakers do not sit together. All the 3 speakers ABC do not sit together means total arrangements minus number of arrangements in which ABC sit together. So what is total arrangements? 10 factorial minus number of arrangements in ABC sit together means consider ABC as 1 unit, remaining 7 as 7 units. 8 units can be arranged in 8 factorial ways and ABC among themselves can be arranged in 3 factorial ways. So 10 factorial minus 8 factorial 3 factorial. Let us write 10 factorial as 10 into 9 into 8 factorial minus. Now we can take 8 factorial common. Then you get 90 minus 6, which is 84 into 8 factorial. Option D. Next. The number of 3-digit odd numbers divisible by 3 that can be formed using the digits 1, 2, 3, 4, 5, 6 when repetition is not allowed. You have to find number of 3-digit numbers divisible by 3. Repetition is not allowed. What is the condition for a number to be divisible by 3? Sum of digits in that number should be multiple of 3. For example, if you take 1, 2, 3, Here the sum of digits is 6, which is multiple of 3. So the numbers obtained by using these 3 digits are divisible by 3. How many you can get from this? 3 factorial. 1, 2, 3, 3, 2, 1, 2, 1, 3, like that you get 3 factorial. Next, after 1, 2, 3, which more combination you can take so that sum is multiple of 3? 2, 3, 4. Huh? Here you get 3 factorial again. Next, 3, 4, 5 is also possible. 3 factorial here. Here sum is 12. Next, 4, 5, 6. Here also you get 3 factorial, which is 6 altogether 24. Option C. Next, X denotes the number of ways of arranging M boys and M girls in a row so that no two boys sit together. Since condition is on boys, first you have to arrange girls. M girls can be arranged in M factorial ways. No two boys should sit together means you have to arrange boys in between the girls. First arrange M girls. In between M girls there will be M plus 1 gaps for M boys, which can be arranged in M plus 1 P of S. So first arrange M girls in M factorial ways, and in between M girls there will be M plus 1 gaps for M boys. So M plus 1 PM, that is X. And what is Y? Y gives the number of ways of arranging M boys and M girls in a row and around a circle so that boys and girls sit alternatively. So Y is the number of ways of arranging M boys and M girls in a row such that boys and girls sit alternatively. So Y will be 2 into M factorial into M factorial. Z. Z is arrangement around a circle. In case of a circle, first arrange M boys in M minus 1 factorial ways. Between M boys, there will be M gaps for M girls, which will be MPM. So this is M minus 1 factorial into M factorial. Now what is X is to Y is to Z? This is M factorial into M plus 7 PM means M plus 1 factorial by M plus 1 minus M. That is 1 factorial. So what will be X into Y? X is to Y is to Z. First you can cancel M factorial. Then what is left out? M plus 1 factorial is to 1 M factorial gets cancelled is to M minus 1 factorial. Now M plus 1 factorial can also be written as M plus 1 into M into M minus 1 factorial. 2 into M factorial can be written as M into M minus 1 factorial is to M minus 1 factorial. Now you can cancel M minus 1 factorial also. So what you get then? M plus 1 into M is to what you can cancel M minus 1 factorial. So 2M is to 1 should be. Next, a village has 10 players. A team of 6 players is to be formed. So out of 10 we have to select a team of 6. 5 members are chosen out of these 10 players and then the captain is chosen from the remaining players. So first you have to select 5 members from 10, which can be done in 10C5 ways. And remaining 5 players, you have to select one captain, which can be done in 5C1 ways. So 10C5 into 5C1. Simplify this. 10C5 is 10 into 9 into 8 into 7 into 6 by 5 factor 120 into 5. 6 20 times, 10 2 times, 2 4 times. So 5 was 20. 149s, 1260, option A.